Hello, today we look at this interesting series problem. The question says the sum sine squared 1 degree plus sine squared 2 degrees plus sine squared 3 degrees plus sine squared 89 degrees plus sine squared 90 degrees is equal to A 44, B 44.5, C 45, D 45.5 and E 46. As we can notice, the series involves the sum of squares of sines of angles from 1 degree up to 90 degrees. Okay, in order to solve this problem, there is the need to revisit some basic notions of trigonometry, and the first one is the notion of complementary angles. Two angles are complementary if they sum up to 90 degrees. Hence, theta and 90 degrees minus theta are complementary angles, so that the cosine of one of them is always equal to the sine of the other. Example, cos 30 degrees equals sine 90 degrees minus 30 degrees. Cos 30 degrees equals sine 60 degrees equal root 3 over 2. Another notion that we need to see is that of the Pythagorean identity, sine squared theta plus cos squared theta equals 1. There are, however, hidden variants of this identity, because cos theta can be replaced by sine 90 degrees minus theta, just like sine theta can be replaced by cos 90 degrees minus theta. So we can have a variant of the Pythagorean identity as sine squared theta plus sine squared 90 degrees minus theta equals 1, or cos squared theta plus cos squared 90 degrees minus theta equals 1. Okay, we have some two examples. Sine squared 1 degree plus sine squared 89 degrees equals 1. For the simple reason that sine squared 1 degree plus cos squared 1 degree, according to the Pythagorean identity, is supposed to be 1. But then cos squared 1 degree can be replaced by sine squared 90 degree minus 1, which is sine squared 89 degrees. That is why this sum will still give 1. Just like we can decide to express both terms in terms of squares of cosines of each angle and its complementary counterpart. So another example would be cos squared 5 degree plus cos squared 85 degree equals 1, because cos squared 5 degree plus sine squared 5 degree equals 1, again according to the Pythagorean identity, but sine squared 5 degree can be written as cos squared 90 minus 5, which is the same as cos squared 85 degrees. So generally the conclusion we can have from these variants is that once I have the sum of squares of sines of two angles which happen to be complementary, the result is 1. Just like if I have the sum of cosines of two angles which happen to be complementary, the result will still be 1. This other variant involving sum of squares of sines of complementary angles is very crucial for the solving of our series. So going to the problem proper, the series given, we can write it in more elaborate form so that we see clearly how the terms come about. Sine squared 1 degree plus sine squared 2 degrees plus sine squared 3 degrees plus sine squared 87 degrees plus sine squared 88 degrees plus sine squared 89 degrees plus sine squared 90 degrees. The strategy here then to evaluate the series is to pair up the terms in such a way that the square of the sine of one angle is added to the square of the sine of the complementary counterpart of that angle. Hence, it will require that we pair up sine squared 1 degree with sine squared 89 degrees, as 1 degree and 89 degrees are complementary angles. We'll also pair up sine squared 2 degrees and sine squared 88 degrees, because 2 degree and 88 degrees are complementary. Just like we would also pair sine squared 3 degrees with sine squared 87 degrees, because 3 degree and 87 degree are complementary. So presenting the pairs, we would have sine squared 1 degree plus sine squared 89 degrees, because this pair gives us 1. So all the pairs would be written involving complementary angles up to the last pair, which is sine squared 44 degrees plus sine squared 46 degrees. You can see again that the angles involved, 44 and 46, are complementary as they add up to 90 degrees. So overall, in the first half of the series, the terms have been paired up from the first term, which has 1 degree, to the 44th term, which has 44 degrees, so that we have 44 pairs that involve the first 44 terms, and after that the terms from the term in 89 degrees down to the term in 46 degrees have also been paired up. And clearly we can see that for the terms from the first to 89, the term in 45 degrees has been left out. So together with the term in 90 degrees, we can add to the 44 pairs and we will now have the series completely. So presenting the results then, as already said, each of the pairs from the first to the 44th give a result of 1, as already explained in the previous part of the video. The result of each pair being 1, then we have to sum 1 44 times, because there are 44 such pairs that give 1, and so the series would just reduce to 1 plus 1 plus 1 plus the last 1, which is the result of the 44th pair, then plus sine squared 45 degrees, and the sine of 45 degrees is 1 over root 2, plus sine squared 90 degrees, and the sine of 90 degrees is 1. So in the next step then, we have 1 being added up 44 times. It is simply the same as 44 times 1 plus half. 1 over root 2 all squared is half, plus 1, because 1 squared is 1. So overall we have 45 and a half as the sum of that series, which gives 45.5 corresponds to the key D in the question.